Pilot Victor Glover said it best when Orion crossed behind the moon. Humans probably have not evolved to see what we are seeing. It is truly hard to describe. NASA released the full Flight Day 6 photo gallery on April 7th. Most people scrolled through it, saw beautiful shots of Earth and the lunar surface, and moved on. But when you pull the high-resolution files and go through them one by one, 3 images stand out. 3 anomalies. One question NASA still has not answered. We are going through every photo in that sequence, detail by detail right now. The Earthset. What's on the lunar horizon? The Earthset photo is the one that has been everywhere. Earth sits just above the lunar horizon, half in shadow. The surface below it is bone white and completely still. Orion was sitting at roughly 6,500 miles altitude when the crew shot it through the windows. So you are getting a perspective no human has had since Apollo. It looks like a painting. It does not look real. But here is what people are not talking about. When NASA first posted the Earthset image, it went up as a compressed preview, standard web resolution, the kind of file that loads fast and looks fine on a phone screen. Then about 18 hours later, they released the full high-resolution file. In that high-resolution version, along the lunar horizon line, there are light signatures that are simply not visible in the compressed version. Small and localized, they sit right at the edge where the surface meets the black of space. Now, before you assume this is a compression artifact, it is worth understanding what NASA itself has been monitoring on the lunar surface for the last several years. Since 2021, NASA's Meteoroid Environment Office has been coordinating with amateur astronomers around the world to document what they call transient lunar phenomena, unexplained flashes on the lunar surface. Some are impact flashes, others are outgassing events. But a portion of the catalog does not fit cleanly into either category, and that portion has been growing. The flashes in the Earthset image sit right along the horizon, which places them in a specific band of lunar latitude relative to Orion's position. They are not scattered randomly across the surface. They cluster, and that clustering is exactly what you would expect to see if you were photographing the source region of an ongoing phenomenon, rather than a random impact event. Here is where the timeline matters. This photo was taken right before the crew went into loss of signal. For roughly 40 minutes, as Orion swung behind the moon, there was no contact between the spacecraft and mission control. No telemetry, no voice, no data stream. What the crew photographed in those minutes before going dark is available to us now because of the cameras running on board. There was no live feed, nobody was watching in real time. So the question is not just what those light signatures are. The question is what else the crew was pointing cameras at during the 40 minutes we could not see. NASA's official explanation for the Earthset horizon anomalies has not been detailed. The mission brief describes this as a life support and navigation test. The imagery was incidental documentation, but when you look at the shot framing, Orion's cameras were not pointed at Earth for the horizon glow or for aesthetics. The angle of the shot puts the lunar surface in the lower third of the frame, squarely in focus, not as background. If these signatures are consistent with known impact flash coordinates, then we are looking at documentation of an active surface event captured from an altitude and angle no robotic mission has ever matched. If they are not consistent with known impact flash data, that is a different conversation entirely. Either way, this is the photo NASA led with, the one they chose as the public face of Flight Day 6. The detail most people completely missed is sitting right there in the high-res file on the horizon just before the crew went silent. The far side crater images are where that open question gets a direct answer, and we are getting to those. But the Earthset was only the first photo NASA released. The second one is where things get genuinely strange. The 54-minute eclipse, something in the corona. 54 minutes. That's how long Earth completely blocked the sun from Orion's position in lunar orbit. No human being has ever sat inside a solar eclipse that long. The previous record from Apollo was around 47 minutes. The Artemis II crew did not just break that, they shattered it, and they had cameras running the entire time. To understand why the eclipse images matter, you need to know what the solar corona actually is. It is the outermost layer of the sun's atmosphere, a halo of superheated plasma that extends millions of miles out from the surface. The reason you almost never see it is simple: the sun itself is too bright. The corona's light gets completely drowned out under normal conditions. The only time it becomes visible from Earth is during a total solar eclipse, when the moon's disk covers the sun precisely enough to cut the glare. Scientists have been chasing those brief windows for over a century, setting up instruments along the path of totality, racing against the clock because they get maybe 2 or 3 minutes of data before the moon moves on. The Artemis II crew got 54 of them. From Orion's position, the geometry was different from anything achievable on Earth or in low orbit. The crew was sitting at a distance and angle that put Earth's disk in near-perfect alignment with the solar disk for almost an hour. The corona was fully exposed. The images they captured show it in a level of detail that ground-based totality photography simply cannot match, because there is no atmospheric distortion, no horizon interference, and no time pressure. Here's the part that doesn't add up. The corona images from Orion show structural asymmetries on the solar limb that do not line up with what the models predicted for April 6th. The sun's corona is not uniform. It shifts with solar activity, with magnetic field configurations, with the 11-year solar cycle, and NASA's Solar Dynamics Observatory had been tracking the sun's behavior in the 72 hours leading up to the flyby. During that window, the Solar Dynamics Observatory flagged elevated coronal mass ejection activity. Nothing catastrophic, but the kind of turbulence that produces visible asymmetries in the corona's structure. The images show asymmetries, but they are in the wrong place relative to what the Solar Dynamics Observatory data would predict. One possible explanation is instrumentation. Orion's cameras were not purpose-built solar observatories, but NASA processed these images before releasing them, and the asymmetries survived that process intact. The other angle, and this is where the conversation gets uncomfortable, involves what is visible from lunar orbit during totality that is not visible from anywhere else. The L2 and L3 Lagrange points, gravitationally stable regions in the Earth-Moon-Sun system, sit in positions that make them effectively invisible from Earth. Objects in those regions are always either behind the sun's glare or at angles that defeat ground-based observation. During the 54-minute eclipse window, with Earth blocking the sun and Orion sitting at lunar distance, the geometry briefly opened up. L2 and L3 were theoretically in the camera's field of view. NASA has not released a full accounting of what the cameras were pointed at during totality. The corona images are the ones that made the public gallery. Whether additional frames were captured and not included in the April 7th release is not something the agency has addressed. Whatever the crew saw during those 54 minutes, the descriptions from inside the cabin have been sparse. Victor Glover said it was hard to describe. Commander Reed Wiseman called the eclipse sequence a moment that resets your understanding of scale. Neither of them elaborated further in the post-flyby press briefing. Then the crew swung around the far side, and the cameras kept rolling. The far side craters, a surface that should not look like this. The far side of the moon is not the dark side. That is a common mix-up. It gets sunlight the same as the near side. It just never faces Earth, so no one on the ground has ever seen it directly. What it does not have is any of the atmospheric interference, radio noise, or light pollution that affects every other observation platform we have ever used. When Orion's cameras were running over the far side, they were capturing crater imagery in conditions that no robotic mission, no matter how well positioned, has ever fully replicated. The resolution in the released photos is extraordinary. You can read the texture of billion-year-old impact fields like a topographic map, and several of those craters look wrong. The specific issue is shadow geometry. When you photograph a crater from above, the shadow cast by the crater wall follows predictable rules. Depth to diameter ratio, sun angle, surface albedo, these are well-documented relationships, and planetary scientists use them to build accurate elevation models from orbital imagery. The far side photos NASA released on April 7th show craters where the shadows do not follow those rules. The geometry is off in a way that suggests the interior of certain craters is not simply a bowl of regolith sitting at the expected depth. Something inside them is interrupting the light. The most straightforward explanation is uneven interior topography, rocks, ridges, secondary impact debris piling up in ways that cast irregular shadows. That happens, but the craters flagged in this imagery show the asymmetry consistently across their floors, not in isolated spots. That pattern points towards something structural rather than random debris distribution. This connects to a problem planetary scientists have been sitting with for decades. The far side's crust is measurably thicker than the near sides, in some regions significantly so. Nobody has a clean consensus explanation for why. The leading theories involve early lunar formation dynamics and the gravitational influence of Earth during the Moon's cooling phase, but the models do not fully close. The asymmetry is real, confirmed by multiple orbital missions, and it means the far side is geologically distinct from the face of the Moon we have been studying since the beginning of the space age. Now bring in the flight path. Artemis II is targeting the lunar South Pole for landing. The candidate sites are all documented, all on the near side or the South Polar region, none of them in the far side terrain. Orion's cameras were covering during the loss of signal window, so the question of why the camera array was oriented toward off-plan coordinates during the blackout period isn't academic. If this was purely a systems verification flight, the imaging priorities should have been oriented toward the areas that matter for Artemis III's approach corridor. They weren't. And then there's the smell. During the far side pass, the crew reported an anomalous odor inside the Orion cabin. NASA's post-flight documentation attributed it to hardware off-gassing, a known phenomenon where materials in the spacecraft release trace compounds as they respond to the thermal cycling of spaceflight. That's a reasonable explanation. Off-gassing happens, but the detail was flagged specifically in the post-flight report, which means it was unusual enough to document separately rather than fold into routine environmental data. Off-gassing events during the far side pass, rather than during re-entry or the initial thermal stress of launch, are a timing anomaly worth noting. The crew went silent, pointed cameras at terrain outside the mission's stated area of interest, documented a sensory anomaly that made it into the official report, and came back with crater images that do not behave the way crater images are supposed to behave. As we saw with the Earthset horizon signatures, the far side craters are the most geographically consistent origin point for the flashes captured before the blackout began. The two sets of imagery line up spatially. That's not coincidence. That's a pattern. The pattern NASA hasn't explained, so lay the three images side by side and look at what you actually have. A pre-blackout Earthset shot with localized light clustering on the lunar horizon. A 54-minute eclipse sequence with corona asymmetries that do not match the SDO pre-flyby data. Far side crater imagery showing shadow geometry that contradicts the expected depth to diameter relationships. All three captured inside a single 6-hour window on flight day 6. All three released together, quietly, 18 hours after the flyby concluded. That delay is worth sitting with. Artemis II has been one of the most publicly documented human spaceflight missions in years. NASA has live-streamed crew meals. They have posted real-time orbital tracking. The social media operation around this mission has been constant and immediate. So an 18-hour gap between the flyby and the image release is not standard operating procedure for a program running this level of public engagement. An 18-hour gap is a review. Someone was looking at these files before they went out. What gets released after a review like that is, by definition, what was decided the public should see. That's not a conspiracy. That's how institutional communication works at every level of government science. The question is whether what was decided to release tells the full story of what the cameras captured, or a carefully selected portion of it. If Artemis II was purely a systems verification flight, the imaging record should look like a systems verification flight. It should show approach corridors, docking geometry references, thermal shield documentation, and life support environment data. Instead, the public gallery reads like a survey pass: horizon phenomena, corona structure, off-plan crater fields. The framing of every key image is oriented outward, toward the surface and the sky, not inward toward the spacecraft systems the mission was supposedly there to test. Artemis III is not sending a crew past the moon. Artemis III is landing, and whatever the Artemis II crew documented in that 6-hour window, whatever warranted an 18-hour review before public release, whatever put an anomalous smell in the post-flight report, whatever produced corona images that do not match the models, the next crew will be touching down into it. 3 photos, released quietly, and together they describe a flyby that covered considerably more ground than the official mission brief accounts for. Whatever NASA found on Flight Day 6, the next mission is not a flyby, it is a landing. If you want to know exactly what Artemis III is targeting on the lunar surface, and why the South Pole coordinates matter more than anyone has officially admitted, click on the video on your screen right now. I will see you there.